Length's formula. If we observe in this figure, from O prime, the ray is started and it is moving parallel to the principal axis which falls on the lens, and it should pass through the focal point F1. I prime is the point of image for the object O prime. And here we consider another ray that passes through the optic center P from O prime. And any ray that is passing through the optic center P will not deviate as per the refraction rules. So the ray which is starting from O prime and passing through the optic center P, these will meet the refracted ray at the point I prime. So this point is the image of O prime, of the point O prime. Similarly, here if we observe, point O on the principal axis is formed at the point capital I on the principal axis. So here we will get the inverted image, that is I prime of the object O prime. So here PO is the object distance, PI is the image distance, and PF1 are the focal length respectively. Now, if we observe in this figure thoroughly, we can see two triangles P prime F1 and F1 I prime. So, according to the SAS similarity, two sides have lengths in the same ratio and the angles included between these sides have the same measure. So from the two triangles, we can write it as AB by A prime B prime is equal to BC by B prime C prime. So keeping this in mind, we can apply the same similarity for these two triangles. Then we will get P prime by I prime is equal to PF1 by F1I. This is the equation 1. But from the figure F1I, how we can determine F1I? F1I is equal to PI, the total distance PI minus PF1. Then we will get F1I. So substituting this F1I in the above equation, then we will get the equation like this. P prime by I prime is equal to PF1 by PI minus PF1. Term this as equation 2. Next, in the same manner, we have another two similar triangles in the figure if we observe this side. So these are the O prime P and I prime. O prime P and I prime. So the triangles appear like this if we separate them from the figure. So there are another set of similar triangles. If we apply the SA similarity, then we can write it as O prime by I prime is equal to PO by PI. But from the figure, O prime is equal to P prime. Therefore, we will substitute here O prime in the place of O prime. We will substitute P prime. Therefore, we will get the equation as P prime by I prime is equal to, the same equation will repeat here. Only the difference is O prime is replaced by P prime. That is equal to PO by PI. That is equation number 3. So from the equations 2 and 3, if we compare second equation P prime by I prime. So if we compare the two equations, then what happens? The right hand side is similar. Then we will equate the left hand sides. Therefore, we will get PO by PI is equal to PF1 by PI minus PF1. So, if we take the denominators on to the numerators, if we write the denominators as numerators, then the equation will be PI by PO is equal to PI minus PF1 by PF1. Here the denominator is PF1. So, the right hand side, if you see, if we separate them into two fractions, then it will become as PI by PF1 minus PF1 by PF1. So, here this part will gets cancelled and 1 will be remaining. So, in the next equation, if we see that PI by PO is equal to PI by PF1 minus 1. This is the equation we obtained from the above. Now, on dividing this equation by PI, so the whole equation should be divided with the PI. Then the numerator parts will get cancelled. Therefore, 1 by PO is equal to 1 by PF1 minus 1 by PI will be remained. So, if we take this minus 1 by PI to the other side, then it will become plus 1 by PI. Therefore, the equation we get is 1 by PO plus 1 by PI is equal to 1 by PF1. This is the equation termed as 4. So, the above equation is derived for a particular case of the object while using a convex lens. So, to convert this equation, as we said in the earlier, PO is the object distance, PI is the image distance, PF1 is the focal length. So, we can term it as, and we have to follow the sign convention also. Now, how to take a sign convention? So, if we observe in this figure, the incident rays are in this direction. So, the sign convention towards this direction is plus. If we go before the lens, then it is minus. So, the object distance PO becomes minus U and the image distance is plus V and the focal length PF1 is F. So, keeping that in mind, then if we substitute the values according to the equation, then here PO is equal to minus U, PI is equal to V, PF1 is equal to small f. So, substituting these values, we will get an equation that is 1 by V minus 1 by U is equal to 1 by F. This equation is called lens formula. So, to understand this formula better, when you are observing this video, kindly keep the equations on paper along with me, then you will be able to understand very thoroughly. There is nothing difficult in this aspect. So, if you like this video, just give a like. If you want to share, just share. If you want more videos, kindly subscribe to this channel. So, this is how we will get lens formula. Keep in mind while writing the sign convention for any lens, the 5 points which are given for sign convention, you have to apply for the lens which we are using. So, this is the equation of lens formula. 1 by V minus 1 by U is equal to 1 by F. Thank you.